Hello and welcome to part one of step 5. So step 5, we're going to move into writing proofs. So this is just the basic foundation of how to set up a proof, some of the theorems that we might use, but we're going to really dive into proofs in step 16. But for now, let's just talk about some vocabulary. Some of this you might recognize, hopefully a little bit. Some of it will probably be new, and that's okay. So we have these addition, subtraction, multiplication, and division properties of equality. You might recognize these from Algebra 1. When you started solving equations, you might have gone over these. If not, that's okay. So addition property of equality says that if A equals B, then A plus C equals B plus C. Okay? In other terms, this is just when you add a number to both sides of your equation. Add a number to both sides. So when you're solving an equation, if you have to add to move that constant over, or even the variable, that's going to be your addition property. So similarly, right, if A equals B, then A minus C equals A minus C. Okay, so this is when we subtract a number from both sides. I bet you can see where we're going from here, right? If it's a multiplication property, if A equals B, then A times C equals B times C. Okay, so this is going to be we multiply a number to both sides. Okay, and last but not least, division. But division has a slightly extra part here. So if A equals B, and C does not equal 0, then A divided by C equals B divided by C. We have to have that little extra part so that, remember, we can't divide by 0. Our denominators in any fractions cannot be 0. So dividing a number from both sides. Okay, so those are pretty self-explanatory, hopefully. Those might look familiar. If not, that's okay. So that would be useful when we're trying to solve an equation. The next few are going to come up when we have more geometric proofs. Okay, so the reflexive property is the fact that everything equals itself. So A equals A, B equals B, 7 equals 7. Okay, everything equals itself. Okay, symmetric property. You probably use this in Algebra 1, but you probably didn't know that it was the symmetric property. This one says that if A equals B, then B equals A. We can flip sides of the equation. Okay, you probably saw this in Algebra 1 when you did like x equals 5 is the same as 5 equals x. Okay, if you had to always flip your x to the left side, that's the symmetric property. Okay, our transitive property is a little longer. It says that if A equals B and B equals C, then A equals C, right? If A and C are both equal to B, then A and C are equal to each other. Okay, kind of reminds us of that law of syllogism where we've kind of cut out the repetition of that B. Okay, next one, substitution. So substitution property says that if A equals B, then A may be replaced by B in any equation or expression. Okay, you've seen that word substitution when you solved systems of equations in Algebra 1. You took things that were equal and you replaced them. Like if an equation was solved for x or y, you replaced it. Another way we can use this if we're just simplifying, right? Like if we're showing that we're adding and then we actually add, that would be substitution as well. Okay, next one hopefully is nothing new to us. Our distributive property. Okay, so we'll use variables. We'll say A parentheses B plus C. Remember, when we distribute, we multiply, so this becomes A times B, or AB, A times C, or AC. Okay, the biggest thing is, if you want to make a note, we multiply when we distribute. Okay, next we have our midpoint theorem. So we talked about midpoint already, right? Midpoint is directly in the middle of our segment. So if you want to write out the formal theorem, it says if M is the midpoint of AB, then AM is congruent to BM. Okay, if we wanted to even draw ourselves a nice picture, right? We draw a segment with A and B at the endpoints, M in the middle, and then we could even make those little tick marks to show that M made those two segments the same. Okay, and then our last three, hopefully you notice reflexive, symmetric, and transitive. We've already seen those words, right? We already saw them up here, but notice in these ones, they said equality, equality, equality. In the last three, they say congruence. Okay, so the only difference is it's the same definition, but instead of equal signs, we're now going to have congruent signs. So the reflexive property says that if we have a segment AB, that's congruent, to itself, right? It's also congruent to segment AB. Okay. Symmetric, if we have that a segment AB is congruent to CD, then we have CD can be congruent to AB. They can switch sides. Just like we can write an equation with flipping sides, our congruent statements can switch sides as well. Okay, and then transitive, if AB is congruent to CD and CD is congruent to EF, then we can cut out that CD and say that AB is congruent to EF. Okay, so these definitions you'll see are throughout the notes. I just thought it might be nicer for you to kind of have them all in one spot so you had all the definitions together if you wanted to refer back instead of trying to scroll through the notes and find those definitions. Okay, so let's actually take a look at our first proof. Okay, so you may have done this in Algebra 1. If not, that's okay. You might not have seen it this formal. This is called a two-column proof. pretty literal, right? It has two columns to it. Our first column always is our statements. Second column is always our reasons. So when we're solving an equation, the statements are always going to be the steps at which we are solving the equation, and then the reasons are why are we allowed to do that? Why did we do that? So we always start the proof with our given. So we're always given something. For this, we're given an equation. Okay? And the reason that we are allowed to write that first is because it was given to us. So our reason is always given. You're always going to start with your given first. So that's a giveaway, hopefully. Okay, the next part, hopefully you notice that we took the -5 times the x, the -5 times the 4. That's what we're showing from step 1 to step 2, and that is our distributive property. Okay, so then if you are solving this, right, we have to now fill in a statement. So now it looks like we're using substitution, which this just means that we simplified the problem, okay? So hopefully you can see we probably want to take care of that -5 times 4. So the next line would be -5x minus 20 equals 70. Okay. From 3 to 4, it gives us the statement. Hopefully you're noticing the difference is that this plus 20 on both sides. You might not need to show that plus 20, and that's okay. If you're showing that you're adding to both sides, this is going to be our addition property of equality. We can abbreviate because I can't fit it on the box. The next one says that we're using substitution, which means that we just simplified again, which we actually did the addition. So on the left side, we'd just be left with -5x, and 70 plus 20 would be 90. And then what did we do? Oh, we have to get rid of that -5. So we would divide. So if we're dividing, this would be our division property of equality. If we want to abbreviate, that's okay. We get the idea. And then it looks like, okay, we actually divided, we simplified. So this number 7 would be substitution. Okay. Okay, so that was a 2-column proof. The other kind of proof that we can use is what's called a flow proof. So a flow proof looks like a little flow chart, right? It has boxes and arrows going to the different boxes. So the way that this starts is our statements go into the box, our reasons go underneath the box. Okay, so remember, we're always going to start with our given. So that is y plus 2 over 3 equals 3. And then the reason for that statement is that it was our given. That's how we always start. Okay, this would technically be like number 1 in our 2-column proof, if you want to think about it like that. And that would flow into option 2. Okay, so we can do this a couple different ways. We know that our proof, we're only allowed to use 4 boxes. If you're writing this by yourself, you can use a different number of boxes if you want. The next thing that I would do to solve this is I would multiply both sides by 3. So in my head, I don't necessarily need to show that multiplication. So if I just multiplied the left by 3, I know that all that I would have left is y plus 2. And then on the right, I would have 9. So if I'm just doing it in my head, I get to skip that substitution step. But since I multiplied, this would be my multiplication property of equality. Okay, but then I have 2 boxes left, which probably means that I need to show an extra step. So in this next one, I know I need to get rid of that 2, and I'm going to do that by subtracting. So I'm going to show y plus 2 minus 2 and 9 minus 2. And that was my subtraction property. Okay, and then last but not least, we're just going to simplify. So we're going to use our substitution and show that we were supposed to prove that y equals 7, and that's exactly what we did. And that is part 1. Thanks for watching.